the things that I wanted to talk about today included the internet and saving information. But I think it's really important to show you a couple of things first. So, for starters, if you open up Godot, just vanilla, and you go to your Asset Library Projects tab, you'll see that there's a bunch of templates for things, right? This is kind of like the Asset Library for plugins, but this is like sample projects that you can download. And specifically, what'll probably be really helpful for you going forward is to just type in XR and to look at some of these templates. So we have a couple of good XR templates, and I believe that this person, Mux, is, I think that's Bastian, who makes XR for Godot. So you know that it's the real deal. It's by a couple of people. It's by Malcolm Nixon, who did those videos. Yeah, these folks right here are kind of the big people behind the XR support in Godot. So if you go to the Asset Library projects and you search in XR, you'll see a couple of things. You'll see a web XR template for how to do web stuff. I've already included some of those in the syllabus. But something that's really helpful is this thing called the XR tools. And I have to admit that I've sort of, I guess I've tricked you. I haven't tricked you per se, but there's this plugin called the Godot XR tools that makes using XR it helps you do a lot of things in XR. And I've steered clear of using it for now because I sort of wanted to build out the fundamental building blocks first. But for your final projects, I really recommend looking into it, particularly if you're interested in doing stuff like teleporting movement, or there's a lot of components and stuff that you can use pretty easily for some of this functionality that you're trying to make yourselves. So for instance, I'm just going to go and put this on the desktop. I'll select that folder, I'll make a new folder, and I'm going to install and edit this template. And it says it was created for 4.1. It should be fine to do it for 4.2, so I'm going to say OK. And it's going to take a minute to upload. And it's going to be hard to show off here, obviously, because of headset, blah, blah, blah. But I'll show you at least what it has. And it's the same process for getting it set up on the other computers or getting it set up on your computers at home. So we have all these little things coming in. Boop, 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 boop. Okay, wow. So I might need to enable the plugin. So I'm going to go to Project Settings, Plugins. No, it's enabled. So let's just see what happens when we run it. I don't know if we're going to be able to run it from here without a headset, but we'll try. So it sort of loads. Yeah, and this is where we get kind of stuck. But if we were to run this scene, you would see a bunch of different components. And notably, if you go inside of the... I think it's inside of the Scenes folder. You'll see that we have a lot of demos for different types of VR interactions. So we have a demo for a basic audio, for instance. I would encourage you, I'll show you how to do other audio stuff next week. Again, audio is actually pretty straightforward, but we have this demo for hands with skeletal controllers. We have a teleporting demo. We have these audio example demos, so each of these things sort of emit different sounds. So we have this scene. We also have a teleport demo. And if we open up the teleport demo scene, we'll see that the way they do teleporting is... Let's see. You create this this new node called player body, and you sort of you have a teleport area Oh no, that's this other teleporter. Sorry. It's hard to have this set up without the actual controllers. But what I can do is I will either at the end of the day today or in office hours, I can set this up to work on the PC in the VR room. And if you guys want to try it out, you can try it out that way. But I really recommend looking into this template and these plugins for accomplishing some of this stuff. Okay, so I'm just gonna point you in the direction of this for now, and then next week I'll have a more involved demonstration that you can actually use. But if you're trying to figure out how to do teleporting and movement and stuff, I would look here. This is a really good place to look. And I would also just look on the YouTube channels of both Malcolm Nixon and Bastion. They have pretty good examples of follow-alongable tutorials that you can do. So for instance, if I go to YouTube, I'm going to search Malcolm Nixon. Um, 2 weeks ago, he did a Ready Player Me thing, right? This is this weird VTuber guy. But I know that a couple of months ago, he has this Gato basic VR movement tutorial, which you can do, and this advanced VR movement. So these are really good points of to start off with. If you're trying to get some of this up and running over this next week, okay? And next week, I'll also show you specifically how to do this on the headsets. Cool? Any questions about this particular aspect of it? Or how to do teleporting or moving and stuff? Or how to find these plugins? Yeah.
For when you talk about the demos and the actual Gato file that you just showed us, does it have explanations, or is it just kind of looking through what they did?
So it sort of shows you how to use them. It has instructions in each of them. Oh, okay. And then you can sort of poke through the code itself. But then also, if you go to, so this is a template of a demonstration, or sorry, these are a bunch of sample scenes that they have made. There's also this plugin that you can use called the XR Tools plugin. So if you wanted to, for instance, start a new project, what you can do is, well, I'll quit to the, let's see, Command Shift Q, nope. Command Option Q, Control Q, there we go. So I'm gonna do I'll make a new project. I'll do XR, I'll call it XR Tools Demo. So this, right, so the thing that we just looked at is how you would maybe use this plugin, XR Tools, to create stuff. Now I'll just show you how to actually download the plugin itself to use in your own project. So I'm gonna click Compatibility. I'm gonna go to the desktop. I'll call it XR Tools blank. Select, create, and now if you go to the asset library inside the project and search XR Tools, Tools, you're going to want this one here, this XR Tools for Gato 4. You can just click on it and hit download, and these are all of the actual tools that you can use in order to create some of this type of these types of experiences. So I'm going to click install, and you'll see we now have all these assets that we've just imported. We've installed it successfully. Here I think I do have to go to project settings, plugins, and enable, and then close. And so now inside of our file viewer, we have the folder called XR Tools, and you'll see that it has all these different folders And inside of those folders, we have different like scenes that we can use to kind of speed up our XR development process. So for instance, inside XR, we have this Start XR scene. So if you just want to create a new XR project from scratch, I'm pretty sure you can just take this Start XR scene, drag and drop it in, and this is going to have all of the special boilerplate code that we need in order to like start up an XR project, right? The reason why I didn't show it to you earlier is because we can see it's pretty complicated, right? It's like it's got a lot of stuff going on, but it makes it a little bit easier. So now I think if we were to close this and save this, I'll call it main. Why? Go away. Main, save, play the scene, select the current scene. It like tries to initiate an XR scene, and doesn't because we still need to do more stuff. But this is kind of like the beginning starting point for it, right? And then you can also do things like you can bring in like a player body, and you can bring in some hands and stuff with different shapes, right? So like this is all like a lot, and what I'll do is I will sort of like prepare. I'll do some like cherry picking myself to bring in some nice examples from this for next week. But this is a really good way to try and speed up your development a little bit. And then the final thing I wanted to say was, if you go to the page in the asset library and then click on view files, right, you can go to the GitHub repository itself where they sort of explain like how to use it. It takes you to the website where there's like documentation and stuff, and you can really start to kind of like dig into how this particular plugin works. So they do explain how to use it over here on this site, basically. Does that help a little bit?
Wait, how did you get there?
Yeah. I mean, you can just go to godotVR.github.io, or just inside Godot, right? If you go to the plugin itself, should have a README, I think. Let's see. Inside this folder, we have. Looks like it doesn't have a README, but you can go to the asset library, and when you search for it, any plugin that you find in the asset library, you can open up, and if you click view files, that'll take you to its location on the internet, so to its GitHub repository. Cool? Yeah, and again, I didn't share this earlier because I felt like the built-in XR tools are pretty good for doing some of the basic stuff, and by diving into this too quickly, we can get a little disoriented. But I feel like we're at the point now where you can start to incorporate some of this stuff. So any questions on the XR tools? No? So, I want to turn our attention now to the internet. Here it is. We're on it. This is sort of a weird slideshow, but here we go. So what is the internet? I guess without looking at it, but what do you guys think the internet is? What is it? How does it work?
It has a lot of information.
It has a lot of information. That's true. Where does all the information come from? Huh? It's like a library. In what way is it like a library? Mm-hmm. Like the Dewey Decimal System, sort of. You got to go look stuff up on it. That is a good metaphor in some ways, right? Everything has a place and you have to go and find it somewhere on the internet. How do you technically find things on the internet without, like, Google? Ads? Okay, yeah, that's true. That is a way to find out about things on Google. But, like, let's say I want to get to a specific place on the internet. What do I need to do? You need a browser, yeah.
A link.
You need a link. What is a link? It's a path. It is kind of like a path, right? We have this like www.whatevertheheck.com/wherever the heck, right? It is a lot like the Dewey Decimal System. It's like a path. It's like a place you go look things up on the internet. But when you follow that path, where does that take you to? Like, is it like a man who's sitting in a cabinet somewhere, or like is Ted Kaczynski? Is it like, what is on the other side of that path? Just a page? Yeah. Where's it? Well, where's the page come? Where's the page? A server. A server. Have you heard of? Yeah. What is a server? What is the when we say server? What does that mean? Stores and hosts. Yeah. But, like, is a server like Ted Kaczynski? Is a server like a book? Is a server a piece of technology? What is it not just the computer? It is a computer, right? What is there? Do we think there's any difference between a server and a normal computer? Yeah. What's the difference?
Server's like a domain, like a specific like hub for that specific information.
Uh-huh. It's like doing a specific job. It's like supposed to like serve things, right? It's actually it's a weird question, but like it's kind of like there really isn't a difference between a regular computer and a server. Any of these computers in this room, if you just ran a certain type of code on it, you could turn it into a server and it could serve up web pages. And if you went on the internet and tried to like talk to it, it could get stuff from those web pages. So servers are just other computers. They're just a little bit special, right? They're designed in a specific way to like be turned on all the time. They don't need screens because they don't, you don't need to actually look at them. You put them in a nice big cold warehouse somewhere so that they like can be running all the time, and you plug them in with Ethernet instead of Wi-Fi because Ethernet is faster, or fiber optic cable. But for the most part, the internet is just computers that are plugged into other computers. That's kind of all it is. It's all just regular computers that talk and send signals to other regular computers that are slightly different. So the internet is really just a tab in a browser. The internet's just a network of computers, and some of these computers are bigger than others, but some are smaller than others, but fundamentally everything is just a computer. And it's just computers literally that are plugged into each other, and they are either like plugged in with Ethernet cable, or eventually the Ethernet cable goes, or if it's Wi-Fi, right? The Wi-Fi in this room goes up to like that box, and that box is plugged in with a wire that goes down the building and downstairs and into the street on the ground. Actually, as a matter of fact, let's see if I can find this. Have you ever noticed how there's like spray paint on the ground outside that's different colors? Mm-hmm. There's like yellow spray paint, red spray paint. There's also orange spray paint. Orange spray paint. NYC.
Orange is for water lines.
I believe that water is red. Yellow is gas. Oh man, I forget now. I know that orange is definitely not. Orange is the internet. Orange spray paint on the ground. So there are rules in New York that whenever whenever construction is happening, you need to mark out specifically where things are underground so that the construction workers don't like accidentally cut the internet off, right? Mm-hmm. So if you're ever walking around the city and you see orange lines on the ground, that means there's like fiber optic cable running underground right there, right? And it's really interesting to just sort of walk around the city and like look for all the hidden infrastructure. ECS is a common carrier. It's a company that has fiber optic cable that runs underground in New York. Yeah, I think blue. I don't. This looks like it's New York. Different cities have this, and there's not like a federal law or anything. So it is different in every city. But I believe that this is New York, and we see that like blue is water, orange is like fiber optic cable, yellow is electric, and red might be gas, I think. So if you're ever walking around the city, just sort of try and pay attention to where the orange spray paint is, and you can imagine that that's just fiber optic cable. And does anybody know what fiber optic cable is? It's kind of, it's internet. It is internet, but it's actually really beautiful. If you go to like Times Square and like the M&M store or something, or like these tacky stores, they have fiber optic art, I think. You ever see like these types of like sculptures where you have these like plastic little tubes or whatever, and these lights coming out of it? This is fiber optic cable, and fiber optic cable is, I mean, at the highest grade, it's like glass, and it's literally just glass tubes, and you shine light through them. And light traveling through glass is some of the fastest ways on Earth that we can actually transmit information. And we just send pulses of light very, very quickly at different intervals through these glass tubes underground all day long, and the tubes go under the ground. The tubes are under the ocean. There's like big, huge glass fiber tubes all the way under the ocean around the world. We've enveloped our Earth in a network of glass tubes transmitting little beams of light all around the world, and that is the internet. It's just these tubes that sort of pulse light back and forth, and different computers are plugged into them. Just kind of weird when you think about it that way. And so we've talked about like servers, right? So servers, when you imagine a server, right? A server is often like, well, you can be a server in a restaurant, I guess, but you can also just look like this. Servers are just kind of like these boxes, right? When we think about like industrial grade servers, they sort of look like this, but these are just regular computers in cases in fancy rooms. So that's what a server is. A server sort of sits around all day listening for connections. And the other end of it, right, me, this internet browser right here, or you on your phone, or anybody doing anything on the internet, those are clients, okay? And so a client is a computer that arrives at a website asking for stuff, and a server is a computer that sits around and waits for clients to ask for things. And it then does those things that the clients ask for. And you can kind of think about this like a restaurant, right? Like if you're a patron at a restaurant, you go into the restaurant, you're like, hey, what's on the menu? The server tells you what is on the menu, and you're like, okay, great, I'll get the hamburger. And then the server goes and prepares the hamburger and brings it back for you, right? So that's kind of like the way servers and clients work on the internet. Does that model make sense? Yeah, and that's kind of it, actually. There's not anything else more complicated than that. There's like servers that are bigger than others, and there's some servers that refer you to other servers, and there's different types of clients, but like fundamentally it's kind of just you're either on a website you're either asking a website for something, or you're like waiting around listening for somebody to ask you something, and then you're replying with information. Any questions about that so far? So one of the backbones of the internet is this idea of an HTTP request. Is this familiar? HTTP, right? Where do we see it? So first thing you write, right? You write it like, and actually this is really interesting, right? Right now we don't see this. We don't see HTTP here. We see file, and that's because this web browser can actually just read local files on your computer, right? So if you have a web file, an HTML file, on your computer here in this folder, and you open it up, it opens it up in the web browser, and it has this prefix file, and then it has the file path of the HTML. However, any other page on the internet, you get through this protocol called Hypertext Transfer Protocol. It's one of the fundamental things of the web, and it's in order to get something with the Hypertext Transfer Protocol, you need to you first need to tell the web browser that's what you want to do, right? You say, hey, web browser, use this protocol and use this protocol to go to this address and get this page, right? And there's HTTP and then HTTPS. Does anybody know the difference between those two? That's a good guess. It's not correct, but it's a good guess. Actually don't know if it's either secure or security. It's more modern. It's more encrypted, and it's a little bit harder to use. But it's a more secure version of HTTP. But other than that, it's basically the same thing. And with HTTP, there are 4 important types of requests that it's really helpful to know about. So there are GET requests, which are like, hey, go get something from a website. When you go to a website, that's a GET request. You say, you're talking to that server and you'd say, I would like your home page, please. I would like to get it. And the server responds by sending out its home page, right? Then there are POST requests, which is where you put something onto a server. And there's also PUT requests, which are very similar to POST requests. And for the most part, everybody just uses POST requests. That's where when you like fill out a form and you hit submit, the data that you're sending from the form gets posted to the server. And then there are delete requests, which are requests that delete things off of a server, okay? There's also other requests, but these are the most commonly used ones. And really, the 2 most commonly used ones are GET and POST. As a matter of fact, PUT and delete aren't used that often at all. Any questions about the difference between GET, POST, PUT, and delete? Cool. So, yeah. There's typically when you sort of do something on the internet, you make a request, the client makes a request, and then the server has a response, okay? And requests typically have headers, which are like metadata about the request. Then they have the body of the request, which is the actual data being sent to a server. And typically you only use that for like a POST request. Like if you fill out a Google form that's asking for your name and your email and your favorite day of the week, when you submit that form, you would submit a POST request with like the URL of the destination where you want to send the data to, and then attached to it would be the body of the POST request, which would say like name equals John, favorite day of the week equals Friday. The other thing I said, right? So the body is kind of like any information that is attached to a POST request. And then HTTP responses have headers, and then they always have a body, because even if you're just sort of getting a web page, you need to return the actual content of that web page. Okay? So that's all kind of like abstract. So let's like actually look at it. So it's really easy to do these sorts of requests inside of Godot. So I will show you. I'm gonna quit, save and close. It's fine. So here is our syllabus. Inside of the resources folder, we have this thing called APIs, and I'm going to open up this project called APIs. And you will see a couple of scenes. The first scene we have right here is a simple HTTP request scene, okay? And we're going to use this node called simple HTTP. Oh, it's called HTTP request. I added the simple. But if you want to find it, you just add the node HTTP, and you can add this HTTP request node. Come on, come back. Wah. Here we go. So you can just add this node, and then when you open this node, it's really simple. It has a method called request, and you just give it the URL which you want to request, right? So I'm going to go ahead and hit request, and then it has a signal which it emits when it's done requesting. When the request is completed, it emits this signal that has a result, a response code, headers, and the body. So for instance, first I'll just do it and I'll print out just the result. Okay, so here we go. We're gonna run it. So I'm going to google.com and it returns a 0 as the result, which means good, I think. Pretty sure. We'll send the response code now, which is like, there's classic sort of response codes that that are embedded within the headers for whether or not the request was successful or confused. You might know one response code that's really famous. Does anybody know a famous response code? They're usually like 3-digit numbers. Has anybody heard of 404? Yeah, right? What does 404 mean? Error. Specifically means, it means the thing that you are looking for cannot be found. So the server doesn't know what you're asking for. So for instance, right now I'm gonna run it and we're gonna get a response code called 200. That means A-OK, got it, you did great. But now let's go to like google.com slash like, I'll go to google.com/John Bizark, because I'm pretty sure that I don't have a page on Google. And we'll try it again. 404, look, there it is, That google.com does not have a page dedicated to me. Whatever, fine, I'll make it someday. But not today, right? So that's like, that's what the response codes are, okay? Then you can also see the headers. So I'll print out the headers now. For the most part, don't worry about headers. They're kind of like, they've got a bunch of metadata. They're not really typically what you want to deal with. They're not the exciting part. But they can tell you things about it, you know, about the request that you made and about like the connection and all that. But then the juice is really in the body. So I'm gonna go ahead and print out the body now, okay? So now we're gonna print this out and whoa, what's happening here? This is crazy, right? This is like a huge, apparently this is what google.com looks like. It's kind of nuts. What happened here? What happened here is it is encoded, the response is like a stream of data. You don't need to worry exactly what it is, but like it's basically, it's a UTF stream. This is the way Godot receives responses. So in order to convert it into something that you understand, you need to use this function. You need to say, like, we need to take the thing and then say dot get string from UTF-8. And just by doing that, we're going to convert it into a string that we can read and understand. And then now I'll go ahead and print out that string. So let's run it again. Why did that happen? That's not cool. I did something wrong. Print out HTML. Oh, I'm going to stop printing out the body. Okay. And now we can actually see this is google.com. You can kind of, actually, I'll do it one more time and I'll stop printing out the headers because then it's a little easier to tell where it begins and ends. Okay, here's Google. So when you go to google.com, this is what you get. You get this file that is an HTML file. And this is the way all HTML files start. They say, hey, I'm an HTML file. Then it sort of has some metadata information. And then it has HTML code that gets rendered into the actual file itself, okay? So has anybody seen HTML code before? A little bit? Yeah, you can kind of recognize it, right? This is not really parsed. This is not like a good way to display HTML code because it's just the console. But if you were to take this and put this into like a code editor, it would look nice and pretty. And it would actually, if you like just, we can even do this. We can copy and paste this text. I'm going to go to like a text editor, text edit. I will paste this all in. I'll save it as fake Google as an HTML file on the desktop. Save. Then, if we open it up, you'll see there is a page called Fake Google, and if I open it up with, okay, well that's not what I wanted. If you parse this correctly, it would look like Google, okay? It wouldn't actually like connect to the servers of Google, but this is basically an HTML page that has HTML code in it. Okay. So that's all well and good, right? That's how like pages, that's how like computers get pages and information from each other on the website. But like, what if we want to actually start like interacting with like services on the internet, right? Because the internet isn't just web pages. It's all of these interconnected things, right? It's all the services like get me an Uber or play this video or, you know, stream this music or find this image. There are all sorts of different ways to like exchange data and information over the internet, and everybody who hosts different information on the internet has different ways of sharing that. And a very common way of sharing those that information is with stuff called APIs. But first, before we talk about APIs, I want to explain how URLs work. So URL stands for a Universal Resource Locator, okay? And we use URLs to go to regular websites and stuff, but we also use URLs to go and get information specifically from servers. Like servers don't just have to return web pages, they can return all sorts of information, right? They can return just a picture or a number or a stream of data. And so we use URLs to like get things off of the internet. And the way URLs break down is they have the address of the website followed by the route onto the website, and then they often have like parameters that are passed to the server. So like in this example, we have this website called example.com/page, and we have a question mark, and then we have like parameter equals value, ampersand, another parameter equals another value. And the way it works is, right, example.com is the website, /page is the route to the specific page. Then we have this question mark, which like lets the server know that we have some parameters that are coming. And then we have key value pairs, where we have the name of the parameter followed by the value itself. And this ampersand signals that there's like another value afterwards. Does that make sense? Can anybody think of why we might want to pass parameters to a website or a server?
There's different parts to a website.
There's different parts to a website, and like it also helps you, like what would it help you access?
Maybe if you were on the home page and you clicked a button, that would be another parameter.
So if you click a button, that would refer you to a different route, like a slash, like a page or something, right? So like you go to like your, like if it's Facebook, you can click on your profile page, right? But what would a parameter, in this Facebook example, what could we use a parameter for? Let's say if you want, like, right, facebook.com/profile always takes me to my profile, but it takes you to your profile, right? So like one way you could do that is you could say like, hey, who's the user? You could say like, go to facebook.com/profile, show me who the, and the user wants to be, you know, Clara, or the user wants to be John, right? So you can use parameters to get custom data from the same web page, okay? And so we use all of this together with APIs. And an API stands for an application programming interface, and that's basically a way to like have computers talk to other computers. And there's all sorts of really interesting APIs. APIs often need keys, which I'll show you in a minute. But you can kind of stitch API keys together, APIs, and you use the API keys together to like retrieve certain information. So, for example, I'll go back to Godot, wherever it is, and I'm going to leave this scene, and I'm going to go to this weather scene. So this is a service called Open Weather, okay? And the way this API works is we just use this web address, https://api.openweathermap.org/data/2.5 weather. So this is the address. This is the address we're going to go to get the API call for. And then we're going to pass in some information. We're passing in our latitude, which is like where we are in the world, right? And our longitude. I'm passing in units because I want it in Fahrenheit. And then you need to pass in an API key, which is sort of a thing that you get from the service that lets you know who you are using it, right? And if I were to just take this whole URL and copy it and paste it into like Firefox, for instance, if we went to this website, we would see that we get back this information from the server. We get back the weather, So we have a description of the weather. We have the actual temperature. It's basically 71 degrees right now. And we have our location, which is roughly in Long Island City. And if you want to use this is a free and open source weather API. So you can go to openweathermap.org, I believe. And there's all these different ways you can use this weather API, okay? So if you want to use it, you just click on this one. They want to charge you for this one, but this current weather data is free, so you can go to API doc, and then this is the structure of the API you want to use. So you just you use this web address, and you put in a latitude and a longitude and your API key, and then it will return information for you. Does that make sense? A little bit? So like if you want to use this, and you can just get an API key for free. So you just you just sign in, and then you maybe click API, you create an account, and then it just generates an API key for you, and you copy and paste in that information. You can also, I guess, just use my API key. Just don't spend any money, I suppose. But in this Gato scene, what we have here is we have this HTTP request, and then in the response, we get this response in the form of a JSON object, which I can explain a little bit later. But basically, you just need to parse the JSON object from the string, and then we have the response data, and then I'm actually just setting a label 3D to the main.temp. So when we run this scene, it looks like this. There's the actual current temperature, right? So here's a Gato project that has the real world temperature right now. And you can see it has all of this information in it, right? It has the temperature, the pressure, the humidity. So you could use these either as you could literally display them, or you could use these numbers to make an environment that's responding to the actual temperature or something. But again, there's a whole bunch of different types of APIs out there. Okay, so if you also want, here's a news example. So it's the same sort of thing. We have this HTTP request. And what you do, this is a newsapi.org. And the way this works is you sort of say, everything, and then you say Q equals the topic, and the topic is what the headline is that you're searching for, and then you have a date range. Then you have these other sort of things that you can choose. You can sort by popularity, and then of course you need to have your API key here at the end. And so I've just made this little topic search function, and now I'm going to search for every headline about Obama since April 1st. And so now when I run this scene, you'll see here are all these news stories about Obama that mention Obama, right? And here's the most popular one: 3 presidents and no necktie in sight. But you could do, you could have this be about anything. So you could say string cheese. I don't know if that's going to return anything, but we'll see. Wow. I guess it did. I don't know why string cheese is about these articles, but maybe there's something about string cheese that pulls up these articles. And then the final thing I want to show you is that it's not just, you don't just have to get text and stuff from the internet. You can also get actual resources, right? So NASA has a lot of really cool APIs. They specifically have this really nice one called the Astronomy Photo of the Day, just called APOD. So all you need to do for this one is just say nasa.gov/planetary/APOD, and then you just put in your API key. And then when we get the response, what we do is we parse the response, and then we say response equals json.getData, and then this is actually going to return a URL of an image. And first I'll just print that out. So we'll pause it and run it. So you'll see here's the data that comes back from NASA about the date, the explanation of the image, and then a URL to the photo of the day. So if we go to this URL, you'll see here's the photo of the day, the NASA photo of the day, right? And so what you can do is you can have a multiple of these nodes, right? So what I say here is we get the URL, right? We're gonna go get the HD URL, and we're gonna call this download function inside this HTTP request. And this is just another function called download where we just request the URL, and then when we get the response in here, we simply say we create a new image, and then we say image.load JPEG from buffer body. So we just take the body and we call this function load JPEG from buffer. And then this is going to be an image texture that we can create and put into Godot. So when we run this, it looks like this. There it is. There's the image. And this changes every day, right? So you can get all sorts of stuff from the internet. It doesn't just have to be words. And there's a whole bunch of fun APIs that you can look at. And I know it might be a little out of scope for like the environments and stuff that you're creating, but I think it is important to talk about the internet a little bit because the metaverse really is just the internet with a lot of frills on it. So just knowing how to work with and send things across the internet can really help you in all walks of life. Any questions or comments or concerns?
I think for some reason, like it confuses me. Like I don't know how to explain this, but if you're working in like a 3D project and you pull up this image, is it not technically 2D? So how?
So this is a 2D image. That's true, right? This is just a 2D image right now. But what you could do is like we could easily just sort of say
I guess you could
let's
like place it somewhere.
yeah, so what you can do is I don't know if we've talked about Sprite 3Ds, but we have this node called Sprite 3D, and a Sprite 3D is a nice way of having like a 2D image in 3D space. So something that we could do is sort of say like I'll have this NASA image scene, and then I'm gonna just make all these local, and I'll move this out of here, and I'll delete that, and I will make this a child of this. And now what I'll say is I have this texture, and then instead of creating a texture rect, I will just say Sprite 3D dot texture equals texture. I think I can do this. I hope I can do this. Sort of the whole point. 3D space photo. Texture. And then, of course, we're going to have a camera. There's our sprite. There's our camera. And we'll also add the sun. And now let's see if that works. Didn't quite work. Oh, there it did. It did work. And we can sort of, like, if I were to move the camera back a little bit. No. Did I not save? Maybe I didn't save. Try it again. Yeah, it's working. Just pull it way back. That's a really big photo.
Yeah.
There you go. And if we moved it over here, right, you'll see that it's like, it is technically 3D. It's just kind of hard to tell without an environment. Yeah, that's kind of 3D, right? That makes sense.
Mhm.
Any other questions? I'll leave you with, there's just a bunch of fun APIs, like literally if you just Google weird APIs. Oh no, I already pulled some up. We have a whole API dedicated to dogs. So this is the dog API where you can just get random dog images. This is an open source dog image thing. You can also figure out, it doesn't have to be just random dogs. You could like get dogs based off of breeds, right? You can get the list of all the breeds of dogs they have. So it's a whole bunch of dog APIs. There's also we already talked about the weather. There's also NASA has this APOD one, but it has a bunch of different APIs. And you just all you need to make an API key is just give them a name and email, and then you'll get an API key. And there's like all this stuff that you can ask for. So you can get images and videos from all sorts of stuff. You can get like stats from like things in space right now. Lots of cool stuff you can do with NASA. Right, there's this newsapi.org where you can find all sorts of news information. And all these websites have like clear documentation on how to actually use them, which I recommend just sort of sifting through if you want to use them. And then, of course, there's a Pokemon API. Where you can just find out stuff about your favorite Pokemon. There you go. There's also a Chuck Norris API that tells you Chuck Norris facts, I guess. So yeah. Let's pause it there. We have about 10 minutes left. I'm going to pause recording